Hello everyone, Christophe Prud'homme, I'm a professor at the University of Strasbourg, the coordinator of one of the pilots, Thierry Open Data, so we'll be on that today. With my team, we are four. Track here was in charge of the benchmarking tool, and he contributed a lot in the mission tool as well. Juliette was in charge of valorization, so exploitation, and renovate in charge of energy modeling and interior air quality. So, Thierry Urban Building. Today, I would like to propose you to dive into our pilot. So our motto is map, mesh, simulate, and KPIs, comfort, air quality, energy. So using, in a reproducible manner, EuroHPC systems. So, as you know, buildings are largely contributing to greenhouse gases, as well as final energy usage. And so Europe has set policies in order to renovate buildings. And to do that, to steer the renovation, we need to be able to use simulation with comparable KPIs in a large way. Regarding our framework, what we propose is a rolling energy performance certificate, in French TPE, but it's all over Europe. I checked that with our Greek colleagues yesterday. So a rolling EPC-like system in order to track, follow, hotspot, to screen cities, detect hotspots, and follow over time what is going on. So what is Cterio? Cterio is a tool in order to simulate the energy consumption from the building level up to the city scale, even beyond. You select a region, as I will show you later, and you can compute the energy consumption as well as the comfort and air quality, indoor air quality. We are based on open data. So with the data we have access to, we can reconstruct buildings from all over the world. Of course, we have a lot of missing data, and over time we will include new types of data that are coming in, LIDAR data, satellite data, in order to improve our models. Currently, we are built upon data coming from OpenStreetMap, vector type, databases, open meteo, things like that. And then what we do is that we leverage high-performance computing in order to deploy our calculation on EuroHPC systems or smaller systems. Here you see a reconstruction of the Stuttgart area, 10-kilometer radius, and below the visualization in parallel view of the final results. So the workflow is as follows. This is a very simplified way of presenting our workflow, but I was told that we should simplify things and we shouldn't be too technical. Anyway, we have different stages here. So we have input tools, benchmarking, in order to launch or deploy a large set of computation on EuroHPC supercomputers in order to check scalability, to do regression tests. But today we are going to talk about the GUI that allows to prepare the data set for our simulation. So the GUI allows us to prepare the data, put it on a data management platform. Here we talk about CCAN, but other platforms are supported. The GUI is also in charge of triggering the orchestration to run the simulation. in an automated way directly from the GUI and deploy the pilot onto various systems, including the EuroHPC ones. So those ones we have not yet run on those ones. The EuroHPC analysis report is not even available. So then at the end, we have output tools, ParaView, obviously. I just showed a screenshot of ParaView visualization. But we have also our GUI that will serve in the end as our platform for input and output. And we have also the web. I'll show you how we deploy reports, automated reports on the web. So this is our workflow. Stereo urban building is multi-scale in many aspects. So we go from building to cities, we go from minutes to year, and we have also different ways of dealing with meteorology. We use Open Meteo in order to retrieve the data for wind, temperature, relative humidity, but we have also indoor air quality, outdoor air quality that we can retrieve and feed our model with. But then we need more accurate, depending on the hotspot or the issues, uncertainty that we find in our calculation. Then we need to go into more details, and so we are coupling with WRF, with our colleague from Spain, Grid, to get a mesoscale model with a 1 kilometer resolution grid, and with our Hungarian colleagues, UAP. Then we have a few meters resolution in order to get accurate microclimate condition in the city. Sorry about that. So we are multi-scale in many aspects here. So to finish the introduction, we started the discussion yesterday, and one of the questions by my colleague here was that, but why simulate if we already know what to do as an expert? If we look at a building or a collection of buildings, what brings the simulation? Of course, if you look only at this collection, maybe it's not useful to simulate, but what we want to do is to be able to scale with the same KPIs over large cities, not one city, but many cities, European scale, obviously. But then we want to do also counterfactuals, what is scenarios, A, B, C. And we want to do it in a fair way. We want to prioritize what we do, right? It's not because you are the loudest that you should get the renovation. We need to put figures, budget figures in front of what we are doing. And of course, we want to be future-proof in the sense that we want to make prediction. What happens if we have heat waves, if we have wildfires, extreme pollution, things like that? What happens? So experts are very important. They are essential, of course, because at some point, using the tool, they can target the work of the expert and sequence it over time to decide what is important at the moment. So where are we today? Today we have an end-to-end pipeline to deploy our framework from mesh to KPIs. We scale up to several 100,000 buildings over several months of computation with several EuroHPC machines with some regression tests. And we have already evidence of the correctness of our results based on known benchmarks as well as sensor inside buildings to check our models. So what do we do in our workflow? We start here with the data. We have an address of interest that could be a region, but also points of interest here. So you draw on a map in order to decide what you want to simulate. Could be a few meters to kilometers. Then you check here they tap, so from this, you will get the reconstruction inside the GUI. So it takes, depending on the type of data you want to get, it takes, can take some time, but usually it's from seconds to minutes. And you get a watertight mesh. Then you need to select the type of source for the weather, for the air quality. So this is a very recent addition, so basically over the weekend. And now we can do indoor air quality thanks to this outdoor air quality conditions. And we have also occupancy and use scenarios for the buildings. Currently, we have already scenarios, conventional scenarios that are deployed for different kinds, different categories of buildings. So then we have the advances in the calculation. So we start with the mesh. So we have a watertight mesh that can be refined thanks to adaptive mesh refinement with road, vegetation, elevation, buildings with roofs. Then we can deploy partition. So this is a challenge here to properly partition the data because the mesh doesn't tell you exactly how to distribute properly the computational load. So we have a specific partitioning for our data set. So it's distributed over thousands of cores on various EuroHPC systems. Then we have the energy model where we do dynamic energy simulation with power sizing of the heating system, automated, computing of the comfort indicator, and computing also of the solar masks. So only currently in terms of radiative heat transfer, we consider only the way the building sees the sun. More radiative heat transfer is planned for the future. And finally, we have multi-zone air pollution models for the indoor air quality. Regarding the output, we provide reports for these outputs, various kinds. At the city level currently, I'll show you what we plan in the future. We want to go down to the building for the final reports. With intermediate buildings, for example, intermediate levels of reports, for example, at the district level. So we provide various kinds of statistics over time and metrics for the urban planners. And finally, in terms of visualization, well, we have ParaView, but this is not the tool that we want to use in the end. Oh, already. And then we have the spatial visualization here using the tool. So what is next? So I have to go very, very quickly. What is next is the fact that we want to go from pilot to platform and open the platforms to users, to collaborators. So we need to provide trust and user-oriented runs. We have, of course, a lot of things to provide for the physical and geometrical models, so including more or improved radiative heat transfer modeling, improved air quality models. And we have coming very soon ensemble scenarios and new queues afterwards. And regarding visualization, we want to use our GUI in order to do the full visualization also in the output, and as we walk in the street or as we look globally at the city or at the district to see the statistics on 2D frames inside the 3D environments. We use Qt as a visualization framework, and it supports all this. So this is coming probably in 2026 as we have ordered. And from the GUI, we deploy dashboards that have been developed inside the GUI on the web. These dashboards are already available. We deploy them currently from the simulation. You can check the website cases.tierius.fr. Finally, we want to exploit our, I think it's time for us to exploit our framework, TRU. And so to reach industrial and public partners, open the platform, test it on pilot cities, for example, or with real estate companies. So this is, can you put for screen the video? So this is our map mesh simulate video. So here you select the area that you want to simulate. So this is Stuttgart. Here we chose 2 kilometer radius. Then you select load 0 or load 1 details. We are also working on load 2 when it's available. You select the type of objects that you want to reveal, vegetation, roads, roofs. And then you get the mesh here with the elevation, and you can navigate inside the city with different kinds of camera and flight or navigation systems. Then from the GUI, you can select the time that you want, the dates that you want to simulate, the period you want to simulate, the time step, and you select the supercomputers that you want to use and deploy the job. So currently it's quite crude in the sense that you get only a link to the scheduler that launches the simulation, and you can follow the simulation inside the system that we use here. The data set at the end is put on the data management platform, and you will retrieve a URL that where we can visualize the spatial field data here, PNV, PPD, heat, flows, heat flows. You can visualize the mesh if you like. But again, Paradigm is not the tool that we wish to use in the end. This is the GUI that we have developed. Yeah. And finally, you have here an automated report. This is a city scale report, not discrete or building scale. But this is, of course, the objective to reach that and allow the user to really dive into the data, go from global scale to intermediate scale to low level scale. Thank you very much.